Columbia. Yeah.
Okay, now for sure. This always happens with the sound. Okay, sound is actually working correctly now. Got the audio working. All right. Welcome everybody. It's going to be a great day today. We have Dr. Richard Muller, who's emeritus professor from Berkeley. Okay, why don't you go ahead and we'll do take two at introducing yourself and how you got where you are.
Okay. I grew up in New York City. Went to Bronx Science, Columbia. What I really thank them for is giving you a broad education. Same education that an English major gets. It's just that I happen to major in physics. But came out to Berkeley, graduate student, stayed on, did research in a wide range of fields. I worked with Louis Alvarez, who I think had the greatest record of important scientific discoveries, diverse scientific discoveries in the 20th century. He did everything from getting Nobel Prize for his discovery in elementary particle physics to figuring out what killed the dinosaurs with the asteroid impact discovery. I don't call it a theory. So he was my mentor, and I love his way of doing physics. Everything important I know in physics, I learned from him. I stayed on, I became a faculty member. Very diverse research background, everything from nuclear physics to astrophysics well, a wide range of things, applied physics. Most famous for my astrophysics work, two of my projects that I founded went on to win Nobel Prizes, not for me, but for the people who took them over in their later sections.
Which two projects were those?
Well, the first one was the discovery of the microwave radiation non-uniformity.
Okay, like the WMAP.
So that was a project I created, and I was joined by George Smoot, who then took that instrument and put it on a satellite and discovered the microstructure that gave him the Nobel Prize.
Okay, so that was the COBE data, or like the COBE.
That was COBE. That was COBE. That's right. The second project was also astrophysics. I started a project to study supernovas to use them as standard candles to measure the Big Bang. So I worked on that for many years. Eventually, the project was taken over by my graduate student, who completed the work and showed, in fact, that the universe was not slowing down as we had expected, but was actually speeding up. This is the discovery of the dark energy. And I've shared some awards with him for the discovery of that. But he was the leader of the project at the time of the discovery, so he got the Nobel Prize.
Now,
there's a whole bunch of other. He gave a talk once to talk and mentioned all the different things I was working on. Someone came up to me afterwards and said, "Rich, you were working on a dozen different projects, any one of which was worthy of a Nobel Prize." My reaction was, "Yeah." Why would you work on any project that
wasn't
couldn't lead to, and it was such an important discovery that, I mean, I think in some of these things, the Nobel Prize is the least important thing. It's the discovery. I mean, I've made a prediction which could give me a Nobel Prize, that there is a star orbiting the sun. And I playfully gave it the name Nemesis. This is a published theory. When Nemesis is discovered, that's what I will be remembered for. Not all this other stuff I've done. But the Nobel Prize is nothing compared to going down in history like that. But for the last 10 years, 5 years actually, for 10 years I've been working. I retired from teaching. I love teaching. Teaching is very gratifying. But I retired from teaching anyway. And the most recent thing is to start a company to dispose of nuclear waste. And that's really going bang. Going great guns. It's not going to go bang. Nuclear waste doesn't explode, but really having a wonderful time in this. And we hope, my daughter and I are working together. She's my boss. We have a company about 20 people. It's soon going to expand, and we are planning on disposing of most of the world's nuclear waste. So that's a great project. I think it will make nuclear power viable again, which could really help the world in global warming. So we got into this because of global warming. We got into nuclear waste because of global warming, and it looks like it's going to succeed. So I'm really excited about that.
Right. So will definitely, we'll definitely go into more detail on some of those things. One thing that I wanted to, I guess, get a little bit of information on, this is a personal indulgence, is what was it like? How did you choose and what drove you to switch from one topic to another, and in particular, the switch from like astrophysics into at least what I know you for, which is primarily through your books about energy and society and.
Yeah, I never felt I was ever making a switch.
Mm-hmm.
I'm a physicist, but I think a higher level, I'm a scientist. And because I happen to know physics really well, I could do projects in physics, but sometimes bringing that physics knowledge into another field is more valuable. I often think that the interdisciplinary fields, the fields where you're bringing together two things that people didn't realize could be brought together, is really where the most can be done. So I like to keep up on biology. I like to keep up on, well, engineering, on space, on physics, but all the other sciences too. Computer science. There's so much to learn. It's also fascinating. The advice I give students is when they graduate college, make sure their first year out of college, they learn more than they did in their last year of college.
Mm-hmm.
Never stop learning. You get more efficient at learning, and you can keep on learning. And then your second year out, make sure you learn more than you did the previous year.
Right.
And if you keep that up until you're an old guy like me, you can actually learn quite a bit
Uh-huh.
and never stop learning. Never become I mean, some people will give up their physical activity. I mean, I just came back from a 5 mile hike with my daughter up in the Berkeley Hills. That's what I did this morning. But some people will become couch potatoes and let their body go to pot. But more people go to head potatoes,
Mm-hmm.
and they stop learning. And learning is one of the greatest joys in life. You see this in kids all the time. So keep on learning. And that keeps you stimulated and alive, and it's enormous fun. And if you keep that up, you'll start noticing things that other people didn't notice. And that's when I do.
Mm-hmm.
That's when I start up a new project.
Yeah, so I guess there's one project that I worked on that where I felt like I was able to contribute to it in a meaningful way, given my background in physics and also my background just in like analyzing data, and that was the fastest way to board airplane passengers. So there's a paper that I wrote.
Yeah, I love that. I love that. And one of my favorite papers I read in the last few years was a colleague of mine who published a paper on why is it when you knot your shoe that a few hours later the knot gets loose.
Mm-hmm.
And he analyzes the stress on the shoelace and what walking does and so on. I love that. I think, my goal in science is to try to understand everything physical or chemical or, I mean, the spiritual, that's a different matter.
Mm-hmm.
That's a bigger challenge. But to understand everything that's physical, that's what I want to be able to do. If I see something I don't understand, I am attracted to it. I've got to find out, how does it work? Why does it work? How can we understand that?
Mm-hmm. So one of the things, when you were a professor, what are the classes that you focused on, and which ones did you enjoy teaching the most?
Well, I think when I began, I just wanted to teach every class. And sometimes I wonder how anybody can do research without teaching, because when you teach classes, you get to really master the material. I
Mm-hmm.
mean, I'm embarrassed to say that it was only the sort of the fourth time through teaching elementary uh, physics that I really understood and fully appreciated the meaning of entropy.
Uh-huh.
You don't think a student's going to learn that in a week? Well, it takes a professor 4 years to learn that. So I wanted to teach every course. Electromagnetism, nuclear physics, and so on. Each time I taught these courses, I learned more things. I got deeper and deeper into it. And as I say, learning is really makes it worthwhile. The other half, of course, is teaching. I mean, the research is difficult because if you're doing a really first-class project, all of your colleagues will tell you that you're wasting your time.
Mm-hmm.
You're not going to find anything, or you're doing something that's impossible. And then 10 years later, they say that was a great discovery. It was in the air at the time. Yes, you made it. That's wonderful. But you don't get feedback for years when you're doing really challenging research. In teaching, it's amazing how many students don't realize this. In teaching, I'm looking right at the students. And if I say something tricky, and I can see that face of confusion, and then they go, You know how much pleasure that gives me
Hmm.
when I realize they have learned something? So that's the real joy of teaching. You get instant feedback.
Yeah.
You know when you've done a good job, you know when you've done a bad job. A student comes up to you and asks you a question, and my thought is, wow, you could not have asked that question if you didn't really understand what I said. And that gives me great joy.
Hmm.
So teaching gives you instant gratification, and then research is delayed gratification.
So one's the
Great
dopamine
combination.
section. You get the dopamine trigger from the
Yeah,
class.
right.
So, because one of the things that I've started doing is teaching out of Physics for Future Presidents, the book that you wrote. So I have, before I rip this out of my ear, right here. So for those in the audience, Physics for Future Presidents, right there. And then I got this one last week, Energy for Future Presidents. Same book title. It looks like the same cover art to some extent, or at least done by the same thing. And so it was really eye-opening to me. I enjoyed getting more of a physicist's take on this. So let's turn to that. What was it that inspired you or motivated you to write Physics for Future Presidents and to develop that course?
Well, it was the fact that so much policy was being made in government that was missing out on relatively straightforward, non-controversial physics and science. So someone would make a decision about what's going on, and it would be taken over by. I mean, the case of Yucca Mountain, I think, is a good example, but like also global warming, many other issues in which energy in general, there's a misunderstanding, and people make important decisions that affect everybody. In fact, they affect me and my children and grandchildren, and they're making elementary mistakes. And I could shout out, I could write letters to the editor. That's not the way to get things done in politics. What you have to do is educate the future politicians.
Hmm.
So originally the concept was I was going to teach a course, and I was asked to teach the course that was for the uh, what was it called? It was called it was a general physics course
Was it the Physics for
for
Poets?
physics for poets. And I decided I wasn't really that interested in educating poets. The poets don't need the physics. What people who really need it, so I decided I would teach it, but I would rename it Physics for Future Congressmen because I felt they needed this education.
Hmm.
And the whole goal would be to teach them what they need to know in order to make good policy decisions. And so the physics is nonpartisan, it's not controversial, it's well established, and they could learn it because they are smart people.
Hmm.
And a lot of physicists dismiss the poets and the athletes who would take this course because they don't love integral calculus.
Hmm.
They think someone who doesn't do math for fun is not smart, but that's exactly backwards. Smartest people I know are not physicists or Nobel laureates. They're people in the business world, in the political world, where the problems are far greater, their challenges are greater, the amount of information they have to bring in is much greater. In physics, you can often narrow the problem down to a very simple question,
Hmm.
and therefore we can get a good answer, and it's a reliable answer. So physics is that subset of knowledge for which we can all agree, no matter what your politics are.
Hmm.
But the other questions are more difficult and more challenging. So I wanted to reach out to these smart people and teach them what they needed to know so they wouldn't make bad decisions. Eventually, it occurred to me, why am I aiming for congressman? If I take a course, Physics for Future Presidents, people would want to take it.
Uh-huh.
But what course are you taking? Oh, Physics for Future Presidents. So it would bring everybody in. And I was inspired in part by an astronomy course taught by Alex Filipenko, which every year was voted the best class at Berkeley. And he'd get 500 students coming in, and he'd teach them astronomy. And what was the scuttlebutt among professors? Oh, he's such an entertaining lecturer. I went to Alex and I said, I'd like to have your curriculum. Let me see what you're doing. And I was astonished because what made that course so popular was the content.
Hmm.
He really taught a lot of material. This was an eye opener to me. The way you attract smart students is you teach them things. You make them come out of class saying, I'm glad I know that because I need to know that. And I want to tell everybody else about that too, because that's really important.
Hmm.
When I would go into a lecture, I would always pause before I went in, and I'd always say, "What is it I want the students in the class to remember 6 months from now from this lecture?" And the lecture would then be given in such a way that that same point would become forceful.
Hmm.
And so I really wanted to teach future, whether it's a president of the U.S. or a president of a company, it doesn't really matter. Wanted to teach the smart people who don't happen to like math,
Hmm.
but who will run the world and perhaps do the most important things that are going to be done in the world. And let's give them the background of what they need to know so that they won't make the simple mistakes that a physicist would identify immediately.
Hmm. So
That was the
from
concept.
your student feedbacks, what are the points that the students most often bring up as, I guess, most salient, or the things that where they had maybe the biggest epiphany in terms of, wow, I didn't understand that.
Well, let me tell you a little story of one of my students, Elizabeth, who a year after she took my course, she came to my office hour, and I didn't remember her because the class was too large, but she introduced herself, said she took the course a year ago, and she just had to come in and tell me what happened. So, okay, what happened? So she said her family had dinner with a physicist from Livermore, and the physicist was working on controlled thermonuclear fusion.
Hmm.
And so, he was really, it was wonderful to have him there. And she understood more of it than her parents did because she had taken my course. But there was a little quiet after a while as everybody was admiring this great man. And then she said, I think solar power has a future too. And what she said is that he looked at her and he snickered. That was her term.
Hmm.
And said essentially, and then he said, and this is, I'm quoting her, if you want enough solar energy just for California, you'd have to plaster the whole state with solar cells. That's what she told me he said.
Hmm.
And then she said in response, no, your numbers aren't right. Solar power is a gigawatt per square kilometer. And so California, which has we could have 10 gigawatts of electricity with just 10 square kilometers. Well, there's some efficiency, but it's not that much.
Hmm.
And she said it was silent for a while. And she said he thought about it. And then he said, okay, well, your numbers don't sound wrong. I'll take another look at it.
Hmm.
Yes, that's what I want my students to be able to do, to shut up an arrogant expert when he's just giving off the cuff things and not actually remembering the numbers or doing them.
Hmm.
And I found that my students were happy to remember key numbers, like it's a gigawatt of power in a square kilometer.
Hmm.
You don't get all that into electricity, but that's the starting point. And so she could counter a Livermore physicist just by knowing some numbers. I said, look, this is really important to do if you're a president. They teach the pre-med students how to do elementary physics calculations. They say, no, 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 no. You don't want to do elementary physics calculations. You're not going to be an expert in that. You don't want to do that any more than you want a physicist to do elementary medical calculations.
Hmm.
So, but what you want to be able to do is identify when the so-called expert is talking beyond what he really knows.
Hmm.
You need to know some basic facts, some basic numbers. You want to have a feel for things. You want to understand what energy
Like
is,
know the scale.
not confuse it with what we call power. So these are the things when someone when someone says this solar power station has a peak energy of half a gigawatt, you want to immediately say, oh, he said peak energy, but the average energy is only 1/7 of the peak energy.
Hmm.
So they're exaggerating it in their publicity by a factor of 7. So you want to be attuned to all of those things. So you understand what you're talking about, you understand the limitations of different things, and that's the kind of person That's one of the things they need to know to be president. They have to understand people. They have to understand. They have to understand the constraints. So many things you have to understand. But one component of what you should know is the science. I call it the physics for future presidents. And that's what the book. That's what I put in the book. I decided if it wasn't important, I wouldn't put it in. And someone who's going through this course, I'm sure you have experienced this. If you walk out of a classroom and you've heard a lecture and you ask yourself, why do I need to know that? Then the lecture was a failure. For physics for future presidents, it's clear everything that is there is something you need to know. I mean, not if you're just going to go home and watch television, but if you're going to be part of the world, if you're going to be a decision maker, even if you're going to vote correctly, if you happen to live in, let's say, Nevada, and you want to have a thoughtful opinion on the Yucca Mountain facility, what do you need to know to have a thoughtful opinion? I mean, you could just listen to Harry Reid and say, oh, this is the rest of the world. This is the United States wanting Nevada to be a garbage dump. And you can say, okay, I accept that. Or you can understand, well, let's see, is that really what's going on? And what is the danger? What is the value? Why Nevada? Is this something? And you think it through and be able to give a thoughtful discussion on the subject rather than just say, I trust Senator Reid.
Yeah, that was, so I had the first semester that I taught the same class, one of the students was a psychology major and she switched to a physics major and is now in graduate school. I think she's at Princeton now at graduate school. Because
people don't know what physics is.
She's like, everyone should take this class. It was.
Yeah, that's great. Congratulations.
Yeah.
See, that can make your whole year. That's the reward of teaching. I mean, I think we have I think a fundamental human instinct is to teach. That's why humans have gone so far, because we teach each other. And so you get enormous pleasure when you are successful at fulfilling this innate desire.
So in terms of like these kind of general things, what are some of the science points that people miss most often? Like the general public, from your perspective, what are some of the things that people miss most often in their understanding, especially I guess today? Like what are the top things and what are people missing in those things?
There's so many. We can talk about global warming. We can talk about nuclear. Those are the easiest ones because there's so much misinformation on those. Let me make one point about each one of those. So first, I'll talk about global warming. What people miss is the fact that most global warming is expected, according to the United Nations. Most of the global warming of the future is going to come from the developing world, including China. So here's a fundamental number that I've never heard anybody disagree with me. I've said this in many talks. Say if the United States went to zero emissions today, global warming would stop for 3 years. Would actually, or it wouldn't stop. It would just, the carbon dioxide emissions would drop. Okay. And then in 1 or 2 years, they'd be back up to where they were. And after that, they'd fell off. That all the United States can do by cutting our own emissions is slow global warming by about a year. That's it. That's all we could do. So whenever we focus on cutting our own emissions, we're doing almost nothing. Unless in cutting our emissions, we are setting an example that the developing world will want to follow. Now, put it differently, that they can afford to follow. So if we're going to buy electric cars, expensive Teslas, they can't afford to do that. If we are going to go to more expensive energy in order to reduce carbon emissions, they can't afford to do that. So we are not setting an example they can afford to follow. So cutting our own emissions is a feel-good measure, and I just think it's completely misplaced. And I don't know anybody, Democrat or Republican, who's proposing anything other than feel-good measures. So this is a real frustration for me. It's how I got into nuclear waste. So that's another story we can get back to later if you want. The other example is nuclear, where people are unaware. When I go to my class, I like to bring a guide down. Go tick, 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 tick. What's that? It's radioactivity. From what? From the room, from the air. Mostly it's radiation from space. You go to a bank, it ticks faster because the granite is radioactive. So we're surrounded by radioactivity. At 3 Mile Island, after the radioactive release, people went around with Geiger counters. They found they were at twice the level of radioactivity of the rest of the United States.
Mm-hmm.
They didn't appreciate the fact they'd been at twice the level of the radioactivity of the United States for 1 million years because they just happened to have more uranium in the soil.
Uh-huh.
So they were convinced this was all from a leakage. And then one person was interviewed, and they said, "Well, this radioactivity, why are you worried about the little bit from 3 Mile Island when the radioactivity from the ground is so much higher?" And she said, "Well, but that's natural radioactivity.
Mm-hmm.
Somehow natural radioactivity
Is it
is
healthier
okay.
than yeah?
It's okay. We've lived with that for a million
Natural
years."
carcinogens are better than unnatural carcinogens, right?
Yeah. So in radioactivity, there's a real gross misunderstanding of the dangers. Some organizations have been able to take advantage of that by frightening people. Watch out for the environmental organizations that try to frighten you, because that is the easy way to get donations, is to frighten you about something, and you really have to look very closely. And one of the things I did in retirement was to create this organization called Berkeley Earth.
Mm-hmm.
So Berkeley Earth is still going. It publishes global warming data. It's looking at air pollution data. But uh, we looked at such things. For example, there's a big issue with fracking,
Mm-hmm.
in which people are arguing that methane gas from natural gas is far more dangerous than is carbon dioxide. And by ignoring half the information and emphasizing only this, they reach this conclusion it's really bad. And they just ignore this, uh, purposely, I assume. So we've published articles in which we say, "Oh, it looks really bad, but if you take this in, you find it's actually better than carbon dioxide."
Mm-hmm.
So methane is not really a serious problem.
Right, because it only takes like a decade or so to
Leave the air,
leave the
leave the
atmosphere.
atmosphere. Carbon dioxide stays around. Half of it leaves pretty quickly, but the rest of it stays around for hundreds, maybe thousands of years. So carbon dioxide, with its long lifetime, is a long-term threat. The natural gas isn't.
Mm-hmm.
So these are important things. And watch out for environmental organizations, or organizations that claim they're environmental organizations, but act as if their main goal is to get more money.
Mm-hmm. So, in regards to the carbon emissions globally and kind of the energy budget globally, this is something that I point out to my class. Is if you look at the top 20 most populous nations in the world, there's only like 3 that one would consider fully developed. There's the United States, Japan, and Germany, and the bulk of the rest of them, some of them are pretty far along. Brazil, Mexico, but then you have Bangladesh, and you have India and China that are certainly developing, Indonesia. And so when you just make a list of the top 20 people and you count up the number of people in those countries and compare it to the United States, I tell my students, we may, completely revert the United States back to, caveman style lifestyle where there's hardly any carbon footprint to speak of. But it does 2 things. One is it doesn't change anything. And 2 is it removes the company who's in a position to develop technologies. Like it removes one of the most important countries for developing new technologies from the equation, and basically condemns the rest of the world to rediscovering a number of things that we've already found.
Yeah, well, I think you're going a little bit far in saying let's go back to being a caveman.
Uh-huh.
I think the argument is we're a wealthy country. Let's spend the money that we need to spend in order to have zero emissions,
Mm-hmm.
or a more modest, with President Biden saying let's cut emissions by 50%.
Mm-hmm.
What's not mentioned there is the fact that our emissions have been going down. And the expectation is that they will go down probably by 20 or 25% by themselves.
Mm-hmm.
So Biden is only proposing we double that. And my reaction is another meaningless goal. I mean, if we go to zero, we only cut 1 year out of global warming.
Hmm.
That's not addressing the problem. Anytime you talk about global warming and you don't come up with a plausible way to help the developing world have fewer carbon emissions, then you are not addressing the issue of global warming. Now, how can we help them? There are many ways we can help them.
Hmm.
Now, one is to help them with energy conservation. Well, it turns out they're really good at that.
Uh-huh.
And the reason is when you can't afford an electric light bulb because electricity at 10 cents per kilowatt hour is too much of your budget, you wind up getting a more efficient light bulb. People do that in the developing world. They're getting very good at energy conservation. So there are two other things you could do. One is to try to get them off coal.
Hmm.
Coal is the cheapest form of energy. And in many cases, you can get them in China, for example, you can get them off coal by having them switch to hydro, which I don't like because it really wreaks havoc with the environment, or to nuclear or to natural gas. And natural gas is actually the thing they can switch to most quickly. And some people in the United States, oh, no, natural gas is a carbon emitter. Look, if we can get China from coal to natural gas, we could reduce their emissions by a factor of two. And they're the biggest emitter in the world, and that's really important. And
Hmm.
don't throw out the really good because it's not super excellent.
Right.
So I have actually been to China. I have worked there. I started a company to help China switch to natural gas,
Hmm.
and the company failed, but not because of us. It's because if I can put it bluntly, the communist system really doesn't know how to cope with innovation very well,
Hmm.
and they want to micromanage it, and that was not working, and we couldn't get them to do it in a way that would work. But coal to natural gas in China is the one biggest thing we could do in the next decade or two. That
Uh-huh.
would be huge, much bigger than the U.S. cutting its emissions to 50%,
Hmm.
much bigger. The other thing we could do is help the world develop nuclear power. And that's how I got into the nuclear business or came back into the nuclear business
Hmm.
after I retired.
Well, let's go to that now then. When it comes to nuclear power, uh, what are what are the impediments globally, and how do the impediments change based upon the country that you're speaking of?
Yeah, well, the major impediment in the past has been the danger of a nuclear meltdown. And Three Mile Island, Fukushima, Chernobyl, these are all meltdowns. Meltdowns are when the cooling of the fuel is lost. The fuel just gets hotter and hotter and hotter, and it melts. And that's happened now. It's been the source of every major accident is the fuel meltdown. And we know how to avoid that. And there's a whole generation of nuclear reactors which will not melt down. Some of them have fuel that's simply made of such materials that even if you put it on the surface of the sun, it wouldn't melt.
Hmm.
So this stuff just can't intrinsically melt. There are other clever ideas too, things in which the chain reaction automatically turns off if it gets too hot, because the molecules they spread out a little bit, the neutrons leak out, and you don't get a chain reaction. So there's this whole fourth generation of nuclear power that I think there's a consensus, and this consensus is in the United States. You may not know this, but there is an area in the United States Congress in both houses in which Republicans and Democrats have voted together over the last 5 years.
Hmm.
And this is on fourth generation nuclear. So, fourth generation nuclear, the safe nuclear, Democrats and Republicans have done it by voice vote.
Hmm.
They don't like to tell you that there's this agreement because they're making a big deal about the fact that the government is so partisan that you
Hmm.
can't get anything done. Well, except on nuclear, they voice vote. Okay, it's passed. So
Oh, so this
making
that's actually interesting
legislation.
because if it's a voice vote, then it doesn't really go on record either, like what your
Yeah, it just
particular
yeah.
vote is. Oh, so so you can get things to go through essentially unanimously without actually being on record as having voted for something.
And so two major bits of legislation that are passed. One was directing the Nuclear Regulatory Commission to prepare itself with methods and procedures to be able to make licensing decisions on fourth generation nuclear.
Hmm.
Believe it or not, they couldn't do that before. And Bill Gates had to take his reactor and move it to China because he couldn't get approval in the United States because the Nuclear Regulatory Commission didn't have the resources to do that. He's come back now, and the legislation has changed, and so they are now directed to do this, and this is done unanimously by Republicans and Democrats. Another legislation has been a legislation to direct the Department of Energy to spend a certain amount of money helping the development of fourth generation nuclear power. And we're seeing that now. They're putting out requests for proposals. Some initial companies have been chosen already to get this support. So we're moving ahead with fourth generation nuclear, and that's going to essentially remove the nuclear reaction, the nuclear meltdown problem. There's still some people somewhere, people who believe that nuclear reactors can explode like an atom bomb. That's much less now.
I can neither confirm nor deny that my son's chemistry teacher has that misconception.
Oh, yeah. When I was in high school, I went to the Bronx High School of Science, and I remember arguing with my chemistry teacher over something having to do with nuclear weapons. And she said, "You have to accept my word for it. I have more education than you. I have more authority. Accept my word for it." You know what went through my mind? I said to myself, someday I will be more educated than you. I will have those credentials, and I'll still believe what I believe today. Turns out to be true. She was wrong. So I think to some extent, teachers like this serve a purpose. They enable the good students to recognize that you don't accept authority. You have to examine the issues. You have to look at the other arguments. You have to make a decision yourself. If you're a scientist, you can't just accept what someone else says. If Fauci says masks do no good, don't just accept that. If 3 months later he says masks are essential, don't just accept that.
Yeah, so it's something that it actually kind of struck me as something that I want to even see if I can work with the local school district in terms of, like, if for issues that are a bit far afield for the disciplines where it comes up. So like nuclear physics in a chemistry in a chemistry class, to have, like summer workshops or something like that where the teachers can come and we can go into some of the details in the more.
Well, I think educating teachers is really important, and the best ones love to be educated. I have given lectures to groups of teachers who wanted to be educated, and the questions they ask are wonderful. And then I hang around for the discussion as they talk about how can we introduce these concepts into the classroom in a way that they will really impact the students. So the good teachers are really great. There are lots of not so good teachers, and they don't want to learn, and that's always been a problem. But this good student will pick out the good teachers. And so it's unfair because the good students will get a much better education than will the poor students, not only because they're more interested in the subject and they learn more, but also because they pick the good teachers. I was talking to my daughter just a few days ago. We were talking about how she and I, when we had a choice of teachers, always picked the teacher that was tougher, that was harder to take, who would go more into things. And if you could, but anyway, I think getting your son to recognize that teachers are often wrong, and checking things like that is maybe a hidden asset. I used to playfully say, what I want to do in every book I have, I want every chapter that I write of physics for future presidents, I should leave a mistake. And homework problem number one is identify the mistake in this chapter.
I might have to try that sometime.
No. Nobody will use your book if you do that.
But I could do it in a lecture. Like sometime in this lecture today, I'm going to say something.
One thing I used to do though is that if I ever made a mistake in class when writing on the blackboard, if a student would shout out and say that's a mistake, and catch me right away, and the student was right, I had a bag of chocolates. And the student up there, one of 500 students, I would throw them the candy in reward. I had one student who was so disappointed. He was always second in raising his hand. He never got his candy. He never got his treat. I also had fruit for people who wanted healthy. A tangerine. But I wanted people to catch me right away because there's nothing worse than some of my lectures have been videotaped. If I make a mistake on a videotape thing, And then the next lecture, I say, so there was a mistake here, and I'm correcting it now. Still, I will get hundreds of emails from people watching the videotape saying, you made a mistake in the lecture.
Uh-huh.
I said, yes, I corrected the next lecture. But no, I want to be corrected right away and reward the student for doing that. And that means the student has to be trying to understand it as it's happening
Uh-huh.
and be able to recognize when what I said was right or wrong. I used to do this when I was when I was in high school. I mean, the teacher would go along and I'd see a mistake and I'd correct my notes, and then she'd go along and say, "Wait, something's wrong here. Uh, did I make a mistake somewhere?" My hand would go up. Yes, Richard. Yeah, the mistake was on the third line there on the right. They were very grateful.
Uh-huh.
I think I got a good reputation from that.
Yeah.
But that's the best way to go to any sort of a class is to assume the teacher's gonna make a mistake and you can catch it.
Uh-huh. So when it comes to, so that's the nuclear meltdown side. You mentioned that nuclear meltdowns was
Okay.
one of the two issues.
Yeah, the other issue is what they call the unsolved waste issue. Now, if you take nuclear power, once the uranium fuel has used up most of its uranium-235, it is then nuclear waste. You take it out of the reactor, you put fresh fuel in. This waste is highly radioactive. It has many things in it. It's become much more radioactive than it was when it started. Fresh fuel is not very radioactive, but spent fuel, every time you have a fission, you have a nucleus that breaks apart into two parts. And the two parts are usually radioactive. Not always, but almost always radioactive. And they have radioactivity anywhere from a few seconds to a few years. When you take fuel out of a reactor, it's full of these fission fragments, and they're radioactive and they're highly dangerous. So if you were to take some of this fuel rod and sit next to it for a minute, the odds are you would die from radiation poisoning. That's how radioactive it is. So this is the nuclear waste. And for years, as people in Nevada typically know, it was planned it would go into Yucca Mountain. And the state of Nevada was opposing that, and they finally got both Democrats and Republicans to shut it down, to shut down the construction. So if you look around the world, there are many nations that have nuclear reactors, and here's a nice trivia question. The nuclear waste has been removed from these. Typically, nuclear fuel is in a reactor for 3 years, 3 to 5 years. Then you take it out. Now it's nuclear waste. What do you do with that? Well, you store it in a place near the reactor for temporary storage until you have a place to dispose it. So in the world today, how many tons of nuclear waste have actually been disposed as opposed to put in temporary thing? And remember, nuclear reactors have been being used since the 1950s and 60s. So the interesting answer is, it's a number that's easy to remember. 0. No nuclear waste from a nuclear reactor has been disposed. It's all in temporary storage. In the United States, almost all of it is sitting on the surface next to the nuclear reactor that produced it. So that's where it is. And that's been the big issue. People have wanted to shut down nuclear plants for 3 reasons: because they explode like nuclear bombs, but they don't. That's an easy one to answer. They've been asked, they want to shut them down because of the nuclear meltdown problem. That's being answered now. Even Japan has said there should not have been a meltdown at Fukushima. There was a mistake we made. The Japanese analysis actually attributed the meltdown to the Japanese culture. This isn't the US saying it's your culture. The Japanese saying the problem was that the people who recognized the problem didn't think it was proper for them to tell their superiors about the problem because the superiors should discover it themselves.
So that's kind of like
the known problem was not solved.
That's like what happened with, was it Korea Airlines, where for a long time they were having the issue
so
where...
now the Japanese have developed a procedure in which every month the low-level employees are expected to tell their superiors issues that may exist. And once you formalize this and tell them you have to do it, then it happens. So they really believe this sort of thing is not going to happen again. And they're right, because this was a human problem. It wasn't a technical problem. But with the 4th generation, and you're using materials that just can't melt, so the meltdown issue is going away. The third issue is this nuclear waste, for which there's been no solution. And the idea of putting it in a mined repository, such as Yucca Mountain, is a good idea. And the US law specifies that the United States Department of Energy will not investigate any alternative site to Yucca Mountain until Yucca Mountain is completed. Now, that is a law that seems ridiculous.
Uh-huh.
So uh, I can tell you how that came about. It came about at a time when people thought Yucca Mountain would sail through, and they didn't want alternative proposals to slow it down.
Uh-huh.
But Yucca Mountain has totally stalled,
But now it's
and
been encumbered, like everything's
the United
Yucca Mountain's
States
now a
Department
weight
of
on.
Energy is not legally allowed to look at alternatives
Uh-huh.
until the Congress changes that law. And as you know, Congress, even if it's bipartisan, they don't act quickly. So yeah, there are people who are working to change that law, but it hasn't happened yet, and it may happen any year now.
Mm-hmm.
But in the meantime, we're stuck with waste on the surface.
Mm-hmm. Now, when it comes to nuclear waste, when it comes to nuclear waste, what effect on the cost of energy does it have to have a recycling program like what they have in France compared to, like, how does the French nuclear industry compare to the United States nuclear industry?
Okay, in France, they remove the plutonium and then put that back into reactors. But that does not decrease the amount of waste.
Mm-hmm.
Because the waste is primarily these fission fragments, which have no value.
Mm-hmm.
So recycling it only, you do that only if you don't have enough uranium.
Okay.
But you wind up getting exactly the same amount of nuclear waste. And the French have a program for putting nuclear waste underground. They have tunnels underground that they are building to do this. But that sort of recycling is misleading. Many people who are unfortunately the fourth generation nuclear reactor proponents. There are about 70
Mm-hmm.
companies developing fourth generation nuclear reactors. And some of them are misleading the public by saying we will use that fuel over again.
Mm-hmm.
What's misleading is the fuel they will use over again are certain components of the fuel, but the really hot components, the radioactive components, they will have enormous amounts of waste also.
Mm-hmm.
So the people who say the unsolved waste problem is a reason we have enough waste now. In the United States, what is the number? We have, I think, 70,000 tons of high-level spent nuclear fuel.
Mm-hmm.
70,000 tons. Around the world, it's like 500,000 tons.
Mm-hmm.
And this is waste that has no place to go. There are some tunnels being built in Sweden and in Finland. They may be the first ones to put it in tunnels. But my little brief history was having been a professor, one of my last research projects, it all starts with the dinosaurs.
Mm-hmm.
So my mentor and good friend, the Alvarezes, Walter and Louis, discovered that the asteroid impact killed the dinosaurs. And that got me fascinated with things from space affecting things on Earth.
Mm-hmm.
And so I think, what else? What other big disasters are there? The thing that comes to mind are the ice ages. So I started looking into whether the ice ages could be caused by astronomy. It turns out that was the standard theory.
Mm-hmm.
They're caused by changes in the Earth's orbit. I found that really interesting, and that's what led me to write a book about the origin of the ice ages, the astronomical origins of the ice ages.
Mm-hmm.
So I wrote that book and I gave lots of talks. And every time I gave a talk, nobody asked me about the ice ages. Every question was about global warming.
Uh-huh.
So I had to do my homework.
Uh-huh.
Since now I'm a climate expert, I need to find out about global warming too. So I read into this stuff and I was sort of appalled that the science in my mind was poorly done. So I became known as a skeptic. And in my Physics for Future Presidents book, I think that comes across.
Mm-hmm.
There's some things I don't really believe. Eventually I retired as known as a skeptic. And my daughter and I started a company to advise countries on energy policy. And they wanted to know what they should do about global warming. And I said, Elizabeth, I'm not sure I even believe in global warming. And she said, well, why don't we raise some money and do a study
Mm-hmm.
and find out whether global warming is real or not? And I knew that if I got together a bunch of good scientists and we all study this, that at the end of the year, we would all agree on whether global warming was real or not. We don't know whether it would be real or false, but we would agree because that's the way science works.
Mm-hmm.
Really good science. So we raised some money. We got money from wealthy donors. We got some from the Department of Energy. Lots of stories I could tell you about that. But at the end of it, it took us about 2 years. And I was looking at this plot, and my reaction was, my God, global warming is real, and it's caused by humans. And we've addressed every issue that the skeptics raised.
Mm-hmm.
And so I'm really the perfect person if there's a skeptic and talks to me. Either that person is not interested in hearing anything,
Uh-huh.
or if they are actually interested in learning, and that's most skeptics are. Most skeptics know more about global warming than the true believers.
Right.
I can convince them because I have addressed all of these issues. Next issue, yeah, that's the plot.
So,
Right.
and I think one of the things in your book that you pointed out is that it actually started earlier than people usually cite.
It's been going on for 200 years. So originally just from burning of trees in Europe.
Mm-hmm. Let me actually bring something up on this regard that maybe you've heard it, but I think I read it in the book 1493, where he mentions, so there's the discussion about the Little Ice Age that happened in the 1600s.
Yeah.
And in the book 1493, he talks about how the people in the Americas, they had forest management, right? They didn't want forest fires to burn through, and so they did work on forestry, like maintaining a number of things. And then when 90% of the people died from diseases, all of a sudden there was this huge undergrowth that developed in the forests.
Mm-hmm.
And he basically did kind of a back of the envelope calculation that showed that there could have been a significant decrease in the carbon dioxide in the atmosphere because there's all this new growth that happened in the Americas that could have contributed to the miniature ice cube.
Interesting. Yeah. The Little Ice Age is one of these. It was very noticeable to humans. It's amazing how a change of a degree can really have an impact on life, on glaciers in Europe, on civilization in general. Barbara Tuchman's book about A Distant Mirror on the history of the 1400s talks all about the impact of that Little Ice Age starting in Europe, how the climate change was really affecting people. And these little things we don't really understand. The big ice ages we know are due to changes in the orbit of the Earth. That I think is firmly established. And you mentioned that you are a data analyst person. I think that's another thing another skill that's really important. It's been important in my life. Data. I feel like a cookie monster. Data. Data. I want data. And you analyze it, and you learn how to analyze it objectively, and that's really, really super important. But anyway, so I got into the Ice Age stuff. I discovered global warming was real. I wrote an op-ed for the New York Times that they published, which got me fame as the converted skeptic. The title of it was "The Conversion of a Climate Change Skeptic." But I point out in that article that global warming is real and it's caused by humans, and I could really make that case very strongly. And I think I do in these books, but also in peer-reviewed published articles. We make that case. That's established science at this point. But almost everything else you hear about climate change is nonsense. And that's why there's so many skeptics. I had an interview on a TV show with a famous skeptic, and he went on for 20 minutes saying, Bangladesh isn't going to be flooded, and there are not increases in hurricanes, there are no increases in tornadoes, and Hurricane Katrina was not due to global warming. And he went on and on and on and on. And then he paused and he said, Professor Muller, you haven't interrupted me at all. Why not? I said, well, because I agree with everything you just said. And he was taken aback. I said, but you never mentioned global warming. You're talking about all these other things that are attributed to global warming, and they're all nonsense. But global warming is real, and it's caused by humans, and I can show you that. So he's been one of my biggest fans. And this was a skeptic, a real skeptic. He gives out copies of my Physics for Future Presidents book to every politician he meets.
So that's actually, because we discussed that at length, actually, in my class this semester, was what role, because there's a question in your textbook about should scientists exaggerate their results?
Oh, yes.
And so we talked about, like, what are the consequences? What are the downsides of people exaggerating their results, and what effect does it have on, how does that ripple through other claims that people might make?
It's a horrible issue, and I'd say there are two things in the last 30 years that have undermined credibility of science more than anything else. The first is the global warming debate, and the second one is the pandemic. I mean, in which Fauci says, well, 6 months ago I told you masks were unimportant, but I did that because we needed masks for essential workers. Basically saying, I misled you and I lied for your own good. But I don't think a scientist should ever do that. You have to trust in the thoughtfulness, intelligence of your audience. You have to be trusted as someone who will give the objective truth. The number of politicians who admired me for changing my mind on global warming actually embarrasses me. Because, well, of course I changed my mind. We analyzed it. We found something that hadn't been published in a plausible way before. And so, of course I changed my mind. I'm not a hero for changing my mind. That's what we do as scientists. Well, it's not what politicians are known for doing.
Right. Well, and if they do, then they're known as a flip-flopper.
Yes. Right.
So I was looking for a quote that I got out of this book, The Energy for Future Presidents. I have it marked, but I can't flip through it and find it in real time.
Let me while you're looking for it.
Well, I think. Is this it? But it had to do with. Oh, here it is, right here. Okay, so this is the plot. That shows basically the developed world down here and the carbon contribution that we're going to be getting that will come from emerging economies.
That's the plot that shows that most of the global warming is expected by the United Nations to come from the developing world as their economic prosperity increases.
Like that. That's this. I'm doing it backwards, so it's kind of hard for me to see. And then the United States and the developed world is down here, basically flat. But the quote that you had is from the 2007 IPCC report. It hasn't helped that the 2007 IPCC report included a huge mistake. It stated that by 2025, the Himalayan glaciers might melt from global warming, with consequences for China and India.
Right.
There was no science behind this claim. The referees for the report said it should be omitted, but the author, who overrode the referees, left it in because he later stated the statement would have a big impact. And then you go on to say the impact was, as far as China and India, the chairman pointed out that the mistaken statement was just a tiny part of the report. But to China and India, that was the most important statement that was in the report. And it was wrong. So that basically discredits, or one can argue then, well, if this is the most important statement, certainly it's the most important to us, and it's wrong, then why should we rely on the balance of the stuff that's in there?
Yeah, and actually you can't, because they claim it's peer-reviewed. But as every scientist knows, it is not peer-reviewed if the author has the final say to override the reviewers. That's not what we mean by peer review. So it's not a peer-reviewed report, but it's a wonderful compendium of information. It's like Wikipedia. My students are always astonished when they say, well, where can I find out more about it? I say, go to Wikipedia. And they say, but I've been taught by my high school teachers never to trust Wikipedia. So, I never said you should trust it. But you go there, and the best part of Wikipedia or of online, Wikipedia gives you references. And if there's anything important, you can look up the references. And you can figure out what they say, whether how you can justify whether it's true or not. So the IPCC report is a wonderful thing because it gives lots of references. But in science, when we write a scientific paper, you or I write a scientific paper, we reach a conclusion and we justify it based on what we said. And it should be clear consequence of the measurements that we made.
Hmm.
When the IPCC does this, they don't use a scientific method. To make their conclusions, they take votes. And so they vote on what their conclusion should be.
Hmm.
And you have to remember, only a small fraction of the IPCC people are scientists, because the issue of global warming is more than just a scientific problem.
Right. It's economic and
So you should never take the consensus of the IPCC too seriously. It's a wonderful, wonderful resource, and they've done a lot of research. Their plots are very valuable, but you got to look at what the plots are plotting,
uh-huh.
and you've got to be skeptical. This is the basic training in science: is listen very carefully, and then evaluate what you've heard. And if there's something important in it, make sure you check it.
Hmm.
That's
So
objectivity.
yeah, when it comes to with the nuclear waste, why don't we talk a little bit about what your most recent endeavor is then?
Okay. So as I said, I became a global warming believer, and it was my daughter Elizabeth who said, "Well, now that we have concluded from our Berkeley Earth, by the way, go to berkeleyearth.org, and you'll find all hourly updates on the world's temperature and air pollution around the world. So we got deeply into air pollution.
Hmm.
That's another story. We are the best site. National Geographic this month has a big spread on air pollution, and their plot came from Berkeley Earth.
Uh-huh.
So we've really done a great job on that. And the reason we did air pollution is the air pollution argument is the best argument that can be made to China to reduce their coal.
Uh-huh.
And if they reduce the coal, we reduce global warming for free.
Yeah, so that's actually an interesting point, because what that means is that because most people, especially if you're in the developing world and you don't have money to throw around, the acute concerns are more important than the chronic concerns.
And they always will be.
Uh-huh.
Yeah, they will be. And so this air pollution thing is a big issue,
Hmm.
especially in India, where only part of it comes from coal, but they have a horrific air pollution thing. Anyway, so Elizabeth said to me, now that we believe global warming is real, is it bad? And my reaction is, as a scientist, I cannot make that judgment.
Hmm.
The science that people put out there that show it's bad is actually mediocre science. It's pop science.
Hmm.
It's not good science. It's not what would get you, publications in major magazines. It's really poor science, and it will not become good science, whether it's good or bad, because we're talking about economics and human reactions, and those are still where the fuzzy science is. But in my gut, I think it's bad.
Hmm.
And so global warming is real and it's caused by humans. That's solid science. Is it bad? I can't convince you of that,
Hmm.
but I think it is. So let us, my daughter felt the same way. Let us take our next step will be to see what we can do to stop global warming. And in doing it, we will use the same standard of objectivity that we have applied to studying it in the first place.
Hmm.
So we looked at it and we looked at all the proposals, and there were many things that we rejected that are that you're supposed to accept. One of them is the climate tax, the carbon tax. Everybody says carbon tax, carbon tax. I look at it and say that's not going to work. There are other issues about solar energy, and no, I conclude that's not going to work either. So of the things that are going to work, I mentioned them already. There's energy conservation, which is the biggest. There is switch away from coal to natural gas, which is the second biggest. And then the third one is to get nuclear going again.
Hmm.
And we started attending a monthly meeting of people who wanted to examine both pro and against the revival of nuclear power in the world.
Hmm.
I mean, we've basically died down, no nuclear plants in a long time in the US. Germany has shut down their nuclear plants. Japan has shut down their nuclear plants. Nuclear is on its way out, but we concluded that nuclear was absolutely essential. So the impediments were the mistaken understanding that it can blow up like a bomb, and that's something I can tell you stories about, but I think that's easily handled. The meltdown issue, which is also being handled well now, and this movie that I recommend, Pandora's Promise.
Mm-hmm.
If you are still worried about the nuclear meltdown, see Pandora's Promise. I think you can get that online. And it's a wonderful movie about that issue. I highly recommend it. The third issue, though, was nuclear waste and talking to environmental groups, and we talked to 80 of them. The main issue, the main reason for not supporting nuclear power was because of the unsolved nuclear waste issue. And as I mentioned earlier, 0 tons of the 80,000 tons in the United States, but of the 400, 500,000 tons around the world, 0 tons have been disposed of so far.
Mm-hmm.
So it's a serious problem, and let's not accumulate more, they would say. So we were attending this forum, and at one point, someone showed an old idea, that you put it down in a borehole. And I actually knew a lot about boreholes because we had looked at natural gas.
Mm-hmm.
And we'd gone to China to help them develop natural gas, my daughter and I. So we had become experts in this issue. Yeah, what's a nuclear physicist, astrophysicist doing, becoming an expert in fracking?
Uh-huh.
Well, I think when you have a background in physics, you have the capability of becoming an expert. Become an expert means you spend 4 years in earning a degree. By the time you are at my age, you can learn 4 years worth of stuff in 3 months.
Uh-huh.
So you can become an expert in this stuff relatively quickly. And I make a lot of friends in this business. So we were going to China to help them switch away from coal to natural gas. And in this lecture, there's this borehole idea. I said, wow, that's where the nuclear waste should go. Nuclear waste is highly compact. You only get a couple cubic meters of nuclear waste every year from a nuclear reactor. It's not like coal.
Mm-hmm.
where you have thousands of cubic meters of ash. Nuclear waste is very compact, perfect for a borehole.
Mm-hmm.
So I looked into it. I called up my friends, and there was a program. It had been revived. It had been created under Obama to put waste in a nuclear hole. And I looked at it and said, yeah, but why are they doing it the wrong way? They're putting them in extremely deep vertical holes. And in the natural gas business, we had learned that you can go this way and you can go horizontally. If you go underneath a shale layer, that nuclear waste will never make it through the shale layer.
Mm-hmm.
So
do you, if you do, so you're saying that you would bore a hole down and then you do horizontal drilling.
That's right.
Do you choose the layer of rock specifically based on like the composition? Like as you go down, there's different kinds of rock, and some rocks are better for long-term stability or whatever.
There are rocks that have what's called very low permeability. And these are rocks where you can actually measure. Inside rocks, there's always a little bit of water, a few percent.
Mm-hmm.
And you can measure, and that water can dissolve much of the waste. And if that water is moving, it can bring it up to the surface. That's the biggest danger.
Mm-hmm.
So you can actually measure how long that water has been there. And in some cases, it's often millions of years. In some cases, you can show it's been there for 1 billion years.
Mm-hmm.
Well, this is a perfect place. And there is a consensus around the world that the right place to put nuclear waste is buried underground. That's why Yucca Mountain is underground, but at some places, Yucca Mountain's within 1,000 feet of the surface. Mm-hmm. We're going to put it a mile down. And underneath these rock layers, and we've done an enormous amount of science. We started, originally I was going to propose this to the Department of Energy, and a wise friend of mine in the nuclear engineering department said, no, don't propose it to the Department of Energy. It'll go nowhere because they're not allowed to look at new methods. Start a company and then propose it. So we've done that, and we've gotten contracts now with 6 countries around the world, one in the United States, to not to store any waste yet, but to make estimates of what it would cost and how difficult it would be. Mm-hmm. So that's what our company is doing. It's called Deep Isolation, one word, deepisolation.com, and you can look it up online. Mm-hmm. But we are a growing company. There's lots of interest. We're well known in the waste community. There are 3 different trade magazines on nuclear waste. Mm-hmm. And nearly every issue talks about us. My daughter says that's because we're the only exciting thing going on in the nuclear waste world. This new way of putting it, you go a mile down, you go a mile horizontally, In that mile horizontally, the waste fits very nicely. I mean, each waste canister is only 8 to 12 inches across. So it fits in the borehole very
Oh, so how
nicely.
big?
You have
What's the diameter of the holes that you're talking about?
well, 18 inches.
Oh, okay. So you're
And the
not
biggest,
taking the dry storage casks. You're taking
oh, no,
like.
no, no, no. We're going to take the individual. So the storage casks contain lots of what are called fuel assemblies.
Hmm.
A fuel assembly is a little set of fuel rods,
Hmm.
maybe 400 of them, held in a bundle. And this is what's put into the nuclear reactor and removed from the nuclear reactor. So we don't want to do anything with this except put it in a canister, close it up, put that deep underground, and then seal up the hole. And we can watch it remotely using seismic. We can put monitors down to measure the radioactivity, but first we're going to measure the site and show that it has been isolated from the surface for 1 million years or more.
Okay, so you can do that you can do the water measurements and say here's how long.
That's right.
And is it because of do you get those measurements because of like nuclear activation from cosmic rays? Is that?
No, no, it's actually from natural uranium in the rock. So all this rock has a part per million of uranium in it,
Hmm.
roughly. And that uranium decays, kicking out alpha particles,
Hmm.
little helium nuclei. Those alpha particles bang into other particles and kick out neutrons. Those neutrons are absorbed on chlorine, making radioactive chlorine.
Hmm.
But there's also spontaneous fission in which you make iodine, radioactive iodine. And so these things are happening at a very low level, but levels we can measure.
Hmm.
Then the question is, if we look, let's say, at the helium that's produced, because all of our helium all the helium in our toy balloons it's all radioactive waste.
Uh-huh.
It all comes from underground uranium that has fissioned, or I'm sorry, decayed and knocked out alpha particles. The alpha particles go around, they become helium. Now, what you can do is you look at the uranium there and you see how much helium there is.
Hmm.
And from the amount of accumulated helium, you know how long it's been confined.
Hmm.
If it escapes, then there's not going to be much helium. But if it's been building up for 1 million years, you know how much helium is there.
Hmm.
And so if helium doesn't escape, then other things are not likely to escape. But we look at helium, chlorine, iodine. I'll look at all these things. And we've proposed this method. We're the first nuclear waste company to propose it. Quite frankly, Yucca Mountain would not pass this test.
Hmm.
I know a lot about Yucca Mountain, and I consider it safe, but it would not pass this extreme test.
Hmm.
This extreme test is just so reliable that nobody's been able to conceive of any way this nuclear waste can get to the surface. In fact, there is a consensus around the world that nuclear waste should be disposed of underground. Don't send it off to the moon because your rocket might crash.
Hmm.
Don't put it in the deep sea because your container might break loose. Put it underground.
Yeah. Well, and we know that there's like parts of the continents that are, you know, 3-4 billion years old, right? The Kola Peninsula and northern Canada.
Right.
So
we're not so interested in the age of the rock.
uh-huh.
We're interested in the age of the water in the rock because even rock has water flowing through it.
Uh-huh.
And that's what's going to carry away the radioactive waste.
Okay. So with these, so you have a borehole. You're looking at like say 10 centimeters square and a kilometer long. Gives you. Probably shouldn't be doing this live, but so you're looking at
Right.
what like is that 100-meter cubed?
Something like that.
Uh-huh.
Yeah, I mean 10 centimeters squared, so that's 1/100th, or that's 1/100th of a square meter. You go 1,000, so that's like 10 cubic meters.
10 cubic
But,
meters.
but we make them larger than 10 centimeters. We're putting in 30 centimeter fuel assemblies in holes that are actually bigger than that.
Okay, so that gives you another factor of.
Yeah, so the numbers work out. A nuclear reactor, for its entire lifetime, a gigawatt nuclear reactor running for 50 to 70 years would require about 10 of these tunnels. Not a tunnel, 10 of these boreholes.
Uh-huh. Okay. So with this, one of the things that you brought up was solar energy. And so there's a discussion, I mean, people are concerned about the cost, why nuclear is so much more expensive than all these other things, and solar energy is less expensive, otherwise we wouldn't be, people wouldn't use it.
Wrong.
what are the
Oh,
actual
oh,
expenses and how
no, it's cheap because
how do
it's
you respond to
subsidized.
that? I guess.
I say it's cheap because it's subsidized.
Hmm.
Um, and um, and it's used where you can't get any other kind of energy in, where it's expensive to get out. My father-in-law used to live up in the remote wilds of Canada, but he could get cell phone coverage. He used solar energy to charge his cell phone,
Hmm.
the only kind of energy you could get. So no, I mean the problem with solar is it's intermittent,
Hmm.
and therefore you need backup. And when you put in the backup, it becomes much more expensive. Solar has a future, but just not in the next. It's not going to be a dominant form of energy. I mean, China, the number is getting less than 1% of its energy from solar. It gets a huge amount of energy from renewables, but the renewables are the Three Gorges Dam,
Hmm.
which is doing a totally different kind of environmental damage.
Uh-huh.
So they say we're a renewables powerhouse, but it's not from solar and wind. It's from hydro. That's that. Anyway,
How many
um,
gigawatts is the Three Rivers Dam? Do you know?
I don't know the number
So it's more
offhand,
than
but
Grand Coulee. So Grand Coulee is like 6 gigawatts in Washington State. So I
I don't know.
think
My number, I think it's like 30 to 50, something like
that's
that. But
huge.
I would want to check my book. And the problem is it changes the whole river. And they're planning on building more dams that will basically dam the Mekong River, which will affect the whole Mekong Delta
Hmm.
in Southeast Asia. So I don't imagine any environmentalist favors hydro.
Hmm.
I mean, certainly we have the experience in California, um, although it's actually closer to Nevada than of Hetch Hetchy, this beautiful valley in Yosemite that was filled up with water to supply electricity to San Francisco.
Hmm.
No, I don't think hydro. Most places of the world can't use hydro either. Even in Korea, where they have a huge potential for hydro, people don't want it destroying the environment.
Hmm.
People don't like wind anymore now because they say it industrializes the environment. So these are the sorts of things that were being suggested 20 years ago. But once you really start building them, people decide they don't like them.
So
Uh,
a question. One of the calculations that I have my students do is if we were to switch completely to solar energy, solar panels, and it doesn't necessarily matter. You can be really generous in terms of the efficiencies and the lifetimes and stuff like that. And we end up getting something on the order of 1 million square meters of solar paneling per day would need to be replaced. And that's just the paneling itself. That's not talking about any
yeah,
infrastructure that
yeah,
goes along to smooth out
yeah,
the day-night cycle. Um, is this and so what I say to my class, and maybe I'm behind the curve on this, is that we don't yet know what the waste cycle looks like for a lot of renewable energies. I'm not opposed to renewable energies. I
yeah.
think that if all the costs are contained, then you kind of know based on the price which one is
Let me
better.
introduce a concept here that is essential. I call it optimism bias.
Hmm.
And the way the argument goes with solar is, well, of course, it's still more expensive, but the price will go down.
Hmm.
And yes, there are all these problems with the waste, but we can recycle that. And if it's costly to recycle it, the cost will go down. And so people who like solar will dismiss complaints about it through sheer optimism.
Hmm.
But when you bring up nuclear, they will be pessimistic. They'll say you cannot bring down the cost of nuclear. It's been tried.
Hmm.
Uh, and they'll be pessimistic about it. And so they're actually not presenting physics arguments or economic arguments. They're presenting optimism arguments. This is an aspect where if they like something, they're optimistic about it. Now, the fact is, Korea currently produces nuclear reactors that are every bit as safe
Hmm.
as US reactors, and they get online at half the cost.
And what's the difference?
Largely, it's the regulation. So I can give you a few examples, but if you're building a nuclear reactor and you discover there's a way that you can, that there's a problem that you can't quite build it this way, you have to go through regulations again and and get the whole thing reapproved. In Korea, they'll look at it and say, oh, that's a change order. Let's evaluate that, and it's fine. You can go with it. So there are these impediments that have been put in by people who have been afraid of nuclear power to make sure it has the highest standards, which means the most impediments to going through. So much of the cost of nuclear is in the delays that come about because of these impediments that were put in at a time when people felt we didn't need it.
Mm-hmm.
Let's go with coal. That's traditional. Let's just build lots of coal plants. Now, let's not build nuclear plants.
Mm-hmm.
And that's the way it was in the past.
So when were some of these regulations put in? Is this like the late 70s?
Yeah, yeah. Yeah, it was put in largely, I mean, these are issues, each one of which you can argue gives you safety, but the cost goes way up.
Mm-hmm.
And so just by being reasonable, you can cut the cost in half. But the fourth generation nuclear plants are even cheaper because they are simpler and therefore easier. Time is money. And if you could delay, the Sierra Club used to do this. They used to say, all we have to do is delay a nuclear plant.
Mm-hmm.
Because if we can delay it by putting up legal impediments, then the cost goes up because the money is basically not gaining interest. So it was a tactic of the Sierra Club, thoughtfully used in order, because they were opposed to nuclear power. What they could do is delay it, and if they delay it, they would kill it. So the fact is, one could be optimistic that the cost of nuclear could go way down.
Mm-hmm.
I think it can, and I think it will.
Mm-hmm.
What's happening is a lot of environmentalists who once opposed nuclear no longer oppose it.
Mm-hmm.
They oppose it, and they oppose it when it wasn't needed. Why do something that's has dangers associated with it when coal works just fine?
Mm-hmm.
But now with global warming, a lot of environmentalists are recognizing the world doesn't have much of a chance unless we can have inexpensive and safe and waste disposed of nuclear power.
Mm-hmm.
But we can do that. And so nuclear power, I think, will be a big part of the developing world. As the developing world develops its economy, as they become wealthy as we are, which is something we all want to see, they can do this, but they need energy.
Mm-hmm.
And for new energy, the one thing they will be able to afford while growing, besides energy conservation, which is the cheapest, is nuclear. And it's around the clock, doesn't require battery backup, doesn't have many of the other drawbacks.
Mm-hmm. So a few things from your book, Energy for Future Presidents, that stuck out to me, and I hadn't appreciated this. I hadn't thought my way through it. One that was interesting was paper recycling. How that recycling paper, if you put paper underground, you're basically sequestering carbon. And so there are good reasons to recycle paper, but one of them is not that you're all of a sudden saving the planet.
No, that's right. You want it right. Another one that maybe you remember, that's one of my favorites, is public transport.
Mm-hmm.
So I talked to some professor of public transport, who she'd been writing papers on this subject, and said, the public really misunderstands this. Public transport typically does not save energy, does not reduce carbon dioxide. And the reason is, if you're going to take public transport, you want to know that bus is going to come, even if it's not the rush hour. So if you have to wait more than 15 minutes for a bus, you're not going to want to take it.
Mm-hmm.
And so all these empty buses are traveling all over the city all the time. Secondly, they have to cover a lot of the ground, because if you have to walk more than 2 or 3 blocks to get a bus, you're going to take your car.
Mm-hmm.
So you have to have a high density, and only in high density living areas will you actually save energy or reduce carbon by using buses.
Mm-hmm.
So the concept of public transport is highly misunderstood by the public, but not by the public transport scientists.
Mm-hmm. So the other thing that struck me was batteries, and this is something that I've talked quite a bit about in my classes, is battery technology in general. That the energy density in batteries is about 1% of the energy density you get in chemical bonds, which is 1,000,000 times smaller than the energy density you have in nuclear bonds.
Yeah.
It's a different force. And this is another thing that I point out, is like nuclear energy, it's a different force. It has different couplings.
Well, I mean, the fact that nuclear fuel is so compact, to me, is not a big deal, except for the waste.
Mm-hmm.
The engineers are always saying, "Oh, this is really compact. That's good." My reaction is, "Why is that good?" The only answer is because it means compact waste.
Hmm.
But if you're thinking about automobiles, for example, and you realize that a battery is a factor of 30 worse in terms of energy density, you need 30 pounds of batteries for 1 pound of gasoline to store the same energy. And then gasoline, I mean, gasoline in some ways was a miracle fuel because I grew up in the Bronx where our homes were heated with coal.
Hmm.
And they would shovel in the coal and then they would shovel out the ashes, and the trucks would come by and pick up the ashes. Um, with gasoline, you never shovel the ashes out of your car.
Hmm.
That's because all the waste goes right into the atmosphere.
Hmm.
But in terms of convenience, when you pump in gas, you're pumping it in at a rate of megawatts. This energy getting into your car, charging a battery takes much longer. So
Hmm.
these are all problems: the recharge time, the energy density. You can only believe in batteries if you have optimism bias for batteries.
Hmm.
Right now, the original Tesla car, I think 40% of the weight was batteries.
Uh-huh.
And they were expensive because you have to make them lightweight batteries, which means they're lithium ion batteries. And those batteries are not anything that China or India will be able to afford. So the whole concept of the Tesla battery car as addressing global warming was completely misleading. It wasn't, because it was not a technology that the developing world will ever be able to afford.
Uh-huh.
Only wealthy people can afford a Tesla. And that will be the case because lithium batteries are expensive, and they will be expensive.
Hmm.
And they're not going to be improved enormously. And you have to make them so you can recharge them more. And that will reduces the expense, because then you don't have to get new batteries every several years.
Uh-huh. So, you're-
But
so you're saying that I'm not capable of affording a $100,000 or even it's not very often that I get a $30,000 car. It might be a bit of a stretch to assume that the Bangladeshi can
yeah,
get
that's
a
right. That's
$30,000
right.
car.
The batteries are expensive. They're too lithium batteries are fine for a wealthy nation.
Hmm.
I mean, I get an iPhone, and if $50 goes into the battery or $100 goes into the battery, I buy the iPhone anyway, because having a phone that I don't have to charge more than once a day is really worthwhile to me, a relatively wealthy person, just because I live in the United States.
Hmm.
But in most of the world, I mean, battery technology, when you're using a backup for industry, you would never want to use lithium ion. I'm amazed that Tesla is selling these batteries for backup to Google. They never, ridiculous.
Hmm.
Get a cheap battery for backup to Google. You can even use lead acid batteries, and when they run out, you recycle them. But cheap batteries are important, and you can put a cheap battery in a automobile for India, and you can go 100 miles, and then you have to recharge it. But for many people around the world, that's fine to go 100 miles. And then the lead is a problem, but you recycle the lead, you make it worthwhile. You buy back the old batteries from the Indian people, and they will not dump them. They will sell them back to you because they can't afford the waste.
Hmm.
So I think there is a future for batteries, but the idea that we should be developing lithium batteries makes sense only in the United States. And again, remember, if we go to zero emissions in the United States, we delay global warming by only a year.
Hmm.
So it's just not worth doing. It's a feel-good technology. It's a, hey, when global warming happens 50 years from now, when it's gotten hot and we're really noticing the effects of global warming, and you're saying, oh, it wasn't my fault, I bought a Tesla. And you're
Hmm.
absolutely wrong. Buying a Tesla was a meaningless gesture for global warming. Buy a Tesla because I like the technology, because I like the quiet when I start up, because I like the acceleration. Don't buy it because you think you're saving the world. You're not. You want to save the world, help India get off coal, help China get off coal.
So what about other, like, what do you think, what role do renewable what role will renewable energies play, and which ones do you evaluate as most useful in the future?
Well, I think wind is pretty good. It has a better duty cycle. It's on 1/3 of the time, unlike solar, which is like on 1/7 of the time. So wind has real possibility. The main complaint against wind is that people used to think it was beautiful because they look at these wind turbines and say, "Oh, wind turbines, they're saving the world." Now they're saying they look ugly. I like trees. I like hills. I don't like wind turbines.
Uh-huh.
So that still has a potential. They require a lot of maintenance, and you've been studying the maintenance for solar power.
Hmm.
I think these solar cells um, are have limited value. The price of solar cells has gone way down. And I think I said in my original book, which was written a decade ago, that the price of the solar cells, you can assume it's zero, but then all the maintenance costs are going to be high.
Hmm.
Uh, Dusting them off, fixing them when they're broken, replacing them after a certain number of years, the damage from ultraviolet and so on. So I'm not really enthusiastic about those being renewables. I think the term renewables was invented in order to discount nuclear.
Uh-huh.
If they said clean energy, you'd say nuclear.
Uh-huh.
So they don't say clean energy, they say renewables, because that's basically using sunlight. But we're not going to run out of nuclear for 1,000 years. We
Uh-huh.
have plenty of uranium. Uh, at one point, it was thought we were running out of uranium, but now the Japanese have perfected a method to extract uranium from the oceans, and the amount we have is basically all we will ever need, conceivably, for 1,000 years.
Hmm. What about so one of the things that I point out is the challenge that you face with renewables, and I think that it makes sense where it makes sense, and it doesn't make sense where it doesn't make sense, and it's unwise to try to shoehorn one renewable technology into an area where it's not competitive, because I guess my perspective is if it's more expensive, it probably has a bigger carbon footprint, because as soon as the cost of things comes down, then there isn't room for a lot of, you're selling a commodity, so the profit margin goes way down, and you make up the money by
Yeah, I think the
volume.
point that you've made, that cost correlates with carbon footprint, is a fascinating one, and one of the most important new ideas I've heard in many years. So I find that very important.
Hmm. So, and I think that so if it makes sense to put solar panels on my roof, I live in the Southwest United States, and so we get lots of sun, and it's really bright, and there's very few cloudy days. Then that would show up in the market. And I actually, when I talk with solar panel installers, I say, like, I want to know the cost without the subsidy, because the subsidy is.
Yeah, but there's a trick there. There's a
Uh-huh.
catch. Okay, and the catch is there's the hidden invisible subsidy that they will not include in.
Hmm.
And the way this works is you put, at least in California, if you put a solar panel on your roof, when you don't need the power, you get to sell it back to the utility
Hmm.
at full retail rate. That's 3 times higher than they have to pay for any other source of electricity.
Wow.
So therefore, it is a subsidy. When you get paid at the retail rate, and they are forced to buy it, which they would not buy it if they weren't forced to buy it. They would get much cheaper electricity, which they can get from a power plant.
Uh-huh.
But if they have to buy it at the full retail rate, that's a hidden
But
subsidy. What it
that
does
doesn't
is
scale. That only scales if you're at like the 1% level of stuff going in back into the grid. If you start supplying 100% of the electricity through that,
then right,
it's a
it wouldn't
positive
work at
feedback
all.
loop, right? Then
That's right. That's right. So that, see, when you talk about subsidies, they can hide those subsidies. So let me give you another hidden subsidy. Okay. In California, we are required to get, I think now, the percentage keeps going up, and I'm not sure what year it is, but by 2030, we're supposed to get 50% of our energy from renewables. Okay. So they're building this stuff and getting renewables. What's happening to the cost of electricity in California? It's going up. Why? Because by law, they're required to make this renewable stuff. And because it's more expensive, we have to pay more for electricity.
hmm.
And that's actually a subsidy. The higher cost of electricity in California has gone up by something like 50 or 60%. But that's not included in most people's calculations of subsidies, because it's a hidden subsidy. It's a tax
Hmm.
that is not labeled tax. It's just cost of electricity. But we are required to pay the utilities whatever it costs them to make the electricity.
Hmm.
Utilities are guaranteed a small profit. And therefore, if we make a law saying the cost of electricity they have to use a more expensive source of electricity. It's never included in as a
Mm.
subsidy, but it really is. So these are the tricks that people have used to make solar more affordable.
So this is actually, this brings up an issue that I've heard mentioned by other people, where one of the challenges that's faced by California is that the people who make the decisions on energy infrastructure and things like that don't really have to suffer the consequences of their decisions.
That's right.
Because the highest temperatures are in like Bakersfield, Fresno, everything. People in the Central Valley, especially the lower Central Valley, where they don't have the political gravitas to be able to say, hey, if we have to spend, because we actually have to air condition our homes. If someone's in San Francisco, they can, for the most part, just open a window. But if someone is living in where we live, we have to have air conditioning, and
but
we have less access to.
You're absolutely right on that. But I think another very important factor for politicians is that they can get bragging rights of having helped the environment without getting the blame of having increased the cost of electricity.
Mm-hmm.
Because the only things they get blamed for are explicit taxes, the state income tax. People are very sensitive to that, but they don't make the connection that the electricity cost going up is something the politicians have put in order to have renewables.
Mm-hmm.
And the problem in my mind with this is not a way. We're not giving an example that India and China will be able to afford to follow.
So someone in India is going to look at that and be like, "We're not doing that. Whatever that is, we're not doing
the
it."
cost of electricity in India because the people will just shut off their lights and everything. By the way, an interesting thing in India, air conditioning is considered a luxury.
Mm-hmm.
So a friend of mine once asked an Indian businessman, "What could you do that would increase your productivity of your factory more than anything else?" He said, "Well, install air conditioning." So why don't you do that? Oh, we're not allowed to. That's considered a luxury. Would it be cost effective? Oh, yes. Our productivity would go way up if people could go into the factory and be comfortable.
Uh-huh.
But you can't put it in because it's a luxury? Right. That's the Indian law.
So, and that's because they don't have the electrical capacity to. Is that the issue that?
Yeah, I'm not sure. I think it was one of these things that legislators do to get the vote of the poor people.
Uh-huh.
The wealthy people will have to pay luxury taxes. Well, we're not talking here about the wealthy people. We're talking about the factory owners.
Mm-hmm.
And it
Well, and the workers.
Too.
Yeah, the people that have to work under those conditions.
Right.
So what about? So I have a response to this, but some of the other things that have come up is, what about like wave technology and?
Oh yeah. Yeah, I've looked at that, and there are some places where wave technology it works. It's remarkably inefficient.
Mm-hmm.
And there are a few places you have to be on the coast. You have to be. It also is unreliable, and it's very low energy density as these waves go up and down. So I recall a facility in which they had a kilometer long wave absorber,
Mm-hmm.
and that would generate about a megawatt. And a megawatt is really not very much.
A megawatt, that's like a megawatt per kilometer.
Yeah, it's and anybody who has been in the Navy is aware of the fact that seawater is an extremely corrosive and difficult environment to work in.
Mm-hmm.
The idea that you could make something that would survive and not have to be replaced every 10 years is not very believable. Tidal power is another that's raised. All of these things, I think, it's like sending nuclear waste to the sun.
Mm-hmm.
People suggest them and they get into the newspapers, but if you really think them through, and groups have thought them through,
Mm-hmm.
there are studies by good scientists who have looked at these things, and waves and tidal power are really don't work very well. Energy storage by pumping water does work if you have the right geology and the right mountains,
Mm-hmm.
but you wind up destroying a beautiful natural environment,
Mm-hmm.
and that could be a price you're willing to pay. San Francisco was happy to destroy Hetch Hetchy Valley in Yosemite in order to get electricity,
Mm-hmm.
but these days we regret that. And I'd love to see a nuclear plant put in at San Francisco, and in exchange, they drain Hetch Hetchy. And yes, it'll take 200 years to recover. But hey, that'll be my great 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 grandchildren. Let's get let's get Hetch Hetchy recovered. Let's start it right now, get it back to nature, and just put in one nuclear power plant. A small nuclear power plant. Hetch Hetchy just isn't that much. They destroyed this beautiful place just for this little bit of electric power, and we could do that with one small modular plant.
Yeah, that's one thing that I point out because I talk about the coupling constants that people you deal with. So when you're dealing with chemical reactions, you're looking at electron volt coupling constants, or like couplings is the typical energy.
Yeah, energy per atom, yeah.
And then with the nuclear, it's an MeV, so you're a million times bigger.
Right.
And with gravity, you're at like little g is the weakest of the coupling constants. And so it's not that pumped hydro can't work as kind of an effective physical store, like a physical battery, as opposed to a chemical battery. But the energy density requires that you have large volumes in order to have a substantial contribution. Right. So to make a substantial
large volumes means you do a lot of damage to the natural environment.
Because it has a bigger footprint, and the same is true with most anything else.
Yeah, I mean, I've thought through things like, well, let's lift up big heavy weights. And it just turns out pumping water is the one thing that makes financial sense.
So with someone mentioned that nuclear power is more expensive. So how is it that nuclear power is more expensive, and what could be done to bring down the cost?
Okay, I think it's largely because of one is regulatory issues. The other is that the old nuclear plants were very large, and they have a very high personnel costs, and those are hard to.
Now, is that for operations or
for operations? For operations, yeah. So the new nuclear plants have very low personnel. The large personnel was, I think, largely to make sure they were super safe. But a lot of this has been computerized now. So I think the cost of nuclear can go way down, and it is happening with what's called Generation 3 Plus, a kind of nuclear reactor that is has a natural safety against meltdown. Typically, a 3 plus reactor is one where if you lose all, the meltdown at Fukushima was because they lost electric power. And so the 3 plus plants don't require any electric power. They still require cooling, but the cooling is all gravity driven, and so they are protected against meltdown. Most experts believe that they are not going to melt down. That's the 3 plus.
So let me go back and note one thing is that the Fukushima plants is actually a Generation 2 plant. So these were ones that were designed in the 60s and built in the 70s. As opposed to ones that were designed, people have learned over the last quarter century, we can make these improvements. And so the nuclear plants, even if we go out and build one that's kind of commercial today.
And the pessimists will say, well, you always think you can make it safe. Back 50 years ago, you thought these would be safe. And so therefore, we don't trust you. Oh, but in solar, we trust the engineers that they can do wonderful things, but we don't trust you if you're in the nuclear business. Well, you and I weren't in the nuclear business 50 years ago. And it's a whole new generation of people looking at this. And as you say, there's a vast amount of experience. And you could also look back on the history of nuclear versus coal and ask which one's killed more people. And coal has been very bad. It just the mining of coal itself. So the history of nuclear was not great, but not as bad as people claim it was. And yes, we didn't do things in ways. There were safety issues that were not anticipated. At Fukushima, if they put the water supply above the plant instead of below it, they wouldn't have needed electricity for the flow to occur. So there are many things that I've been to Fukushima, by the way. I got a tour of Fukushima, carrying my little Geiger counter with me. And so these days, I think the nuclear reactors just can't. Every nuclear reactor accident has been due to a meltdown. And the newest generation not only is safe against meltdown, but most of these designs simply cannot melt down. And they're being made modular, so you don't need $1 billion investment to start out. You can get a small one, and as you need more power, you add more in.
Mm-hmm.
So that's an advantage in the financial world. And they could all be done at the factory
Mm-hmm.
and then carried to the location. So the idea of building it on site, which also causes a great deal of issues with regulation,
Mm-hmm.
can be avoided for many of these new plants. So it's a new day for the nuclear world.
Mm-hmm. Well, this is a great place, a great discussion. Is there any final comments that you would say to, listeners who are concerned about energy, the environment, and I guess even like scientific literacy, global warming, whatever the case may be?
Yeah. No, my reaction is it's fun to learn about this stuff.
Mm-hmm.
and learn about it. I mean, you go to your lectures, you can watch my old lectures online, read the books, read the magazines, inform yourself. You have anybody who's listening to this webcast has enough. Especially if you got here to the end, you can understand this stuff. You really can. You don't have to understand the details of the differential equations of physics. Here, it's the fundamental numbers, and if you know the numbers, you can work things out. And so my admonition to you is trust that you have the capability of learning this stuff enough that you can make judgments as to who's right and who's wrong. You can,
Mm-hmm.
and learn that stuff and teach yourself, and it's fun to learn because learning is our fundamental instinct is to reproduce and to learn. That's what we as humans do.
Mm-hmm.
A lot of animals just reproduce. We reproduce and we learn, and it's through our learning that we make civilization better.
Mm-hmm.
So trust yourself and get into this material. And if there are things you don't understand, ask Jason.
Uh-huh. So I really appreciate you coming on. Let me pitch these books: Physics for Future Presidents and Energy for Future Presidents. And this is Richard Muller from
my latest book, book about the physics of time, called Now.
Uh-huh.
So if you're befuddled by time, that's the book for you.
Mm-hmm.
That's my latest book.
So Richard Muller. So your trajectory at Berkeley. How long were you at Berkeley, and what does...
I moved to Berkeley as a graduate student.
Uh-huh.
Was one of the rare graduate students. I stayed on as a postdoc doing research with Louis Alvarez, and then developed a few new science programs there that were so successful I got national awards, and they put me on the faculty. So one of the rare students from Berkeley that actually stayed at Berkeley and got on the faculty. I was on the faculty until a decade ago.
Mm-hmm.
Then I retired. I started up Berkeley Earth, a nonprofit to study global warming and eventually air pollution. And then 5 years ago started Deep Isolation. Deepisolation.com is the website to dispose of nuclear waste. The goal of storing nuclear waste is to allow nuclear to go ahead, which will save the world from global warming.
Mm-hmm. Excellent. I really appreciate your time. Thank you very much. Look forward to talking to you again sometime.
Bye.
All right. Bye.